2024, times on 2, paper 1. This is HL question 7. It's a sum of root product of root question. A cubic equation have 3 roots, obviously. Find the sum of root, that's negative b over a. Then we have a power 5 polynomial. They share 3 of the roots. Okay, these 3 roots are real, but the power 5 polynomial have a complex roots. So the first thing is complex roots comes as conjugate. So if p plus 3i is one complex root, then p minus 3i is also a root to this power 5 polynomial. Question is find p. So we can probably do sum of root for this power 5 polynomial. So is alpha plus beta plus gamma plus p plus 3i plus p minus 3i. The sum of root is negative b over a, so it's 11 over 2. This is good because if you add, the minus 3i and the plus 3i would cancel out. We also know alpha plus beta plus gamma from before is 7 over 2. So 7 over 2 plus 2p is 11 over 2. Then we should have p being 1. Now you're given that h of half is 0. Alpha and beta are positive integers. Alpha is less than beta. Gamma is a rational number. Ooh, what? Wait, but if h half is 0, then half is a root. We already know h have 2 complex roots, and alpha and beta are integers. So that must mean gamma is half, right? There's no other choice. Gamma is the only one that is a real number, but it's a fraction, so gamma is half. Find the product. So it's quite obvious we should use product of root. So product of root, alpha, beta, gamma, p was 1. So it's 1 plus 3i and 1 minus 3i. That's the product of root. Product of root is the last coefficient over a. So it's negative 20 over a. Except the sign alternate. So b is negative, then positive, negative, positive, negative. So it's negative. You can also memorize, since this is an odd power polynomial, so the product of root would be negative 1 to the power 5, so it's negative. So yeah, you should know that. So gamma is half. If we multiply this out, is that what, 1 plus 9, I think. So it's 20, positive 20 over 2. So the 2 cancel out. 1 plus 9 is 10, divide alpha beta is 2. And hence write down alpha and beta, or 1 and 2. Simply because they must be integers, they must be positive, and alpha must be less than beta. So there's no other choice.